Bismillahirrahmanirrahim. Assalamu alaikum. Welcome students for this lecture number 7 for the subject of operations management, and today hopefully we'll discuss about the linear programming. That is another very important topic related to operations management, and most importantly that is a sort of mathematical technique, that is a sort of step-by-step approach which again helps the operation managers for taking some very important decisions. So important is that technique of linear programming, and generally speaking it will take about 6 to 7 lectures, because this technique important is so much that you can always take some very important decisions in the organizational setting as well as in the operations settings. Before formally discuss and starting our lecture for linear programming, let's have a brief recap what we discussed in the last lecture. Okay students, in the last 3 lectures we discussed about quality management related approaches, and we defined quality, we defined the dimensions of quality. Then we also have a sort of discussion that it is very difficult to actually define that what is quality, because it is directly related to the customer satisfaction, and you know customer is ever demanding, and the demands and the requirements of the customers change with respect to the time and with respect to the different environmental changes, and the introduction of technology also plays a very important role in defining the demands on the part of the customers. So what we do, we link the quality with the customer satisfaction, that is the meeting and exceeding the customer satisfaction is again quality. That is very important aspect of quality, that will have to have the sort of characteristics in the products and services in such a way that our customer should be satisfied, but as well we'll also should try to exceed the customer satisfaction. That is so important with respect to the quality. Then we discussed some important approaches, some important concepts related to quality, that is the concept of continuous improvement, long-term focus, continuous focus. Then we discussed some important points given by Deming, and we also discussed some statistical approaches, and particularly in the last lecture, that is lecture number 6, we discussed some practical implications of some statistical techniques which can be very much helpful for the operations managers to take these particular decisions, to analyze the problem, and then finally to come to the conclusion on the basis of some statistics, on the basis of some information, on that is the information extracted from the raw data that has been collected in the form of some survey. And we also discussed some important diagrammatic techniques like Pareto charts, like check sheets, like fishbone diagram, cause and effect diagram. That is, then we also discussed about Pareto charts, flow charts, histograms, statistical process control. We discussed about the practical implications of these very important techniques, which are the statistical techniques as well as the quality management techniques. Now these are very simple techniques. You must have also read these techniques in the different other subjects like statistics and also in the management. But what we do, we try to focus on the practical implications, that in the operation settings, whenever the operations managers have certain problems regarding quality, then how he should use and how he should implement all of these techniques in order to ensure the quality products, quality services, and most importantly the quality operations, which are actually directly involved in the production of those products and services for our valuable customers. So in the last class we discussed some very important practical implications about all of these quality management tools. Okay class, let's discuss about our today's lecture. We will discuss about the linear programming, that is what is linear programming and how it is helpful again for the operations manager to take some very important decisions. In the linear programming problems, the managers are usually interested to achieve some objectives. Now, we have already discussed that there are the two prime objectives before the managers, that is profit maximization or cost minimization. So these prime objectives will be there throughout that lecture of linear programming. Either the operation manager will be interested to maximize the profit, or he will be interested to minimize the cost. So that is the we will discuss it about linear programming in detail. Then what are the requirements of a linear programming program? Whenever we are trying to achieve some objectives, then every organization has the different limitations, have the different problems, and we will have to achieve those objectives within these limitations. And of course, we can not go beyond these limitations, and we'll have to work under the certain assumptions. So we will discuss that what are these limitations about, and what are actually the requirements of that linear programming objectives, that is maximizing profit or minimizing cost. There are two problems related to linear programming, as we have just discussed, that is the maximization problem or the minimization problem. So one by one we will discuss both of aspects of this linear programming, but in today's lecture we will have a focus on maximizing problem. Then in the forthcoming lecture we will also discuss the minimization problems, that how we can minimize the cost with respect to the particular scenario in that linear programming perspective. Then we will also discuss some important methods which can be used for linear programming. There are two very common methods which are used for solving these problems related to linear programming method. That is the graphical method. That is again a very popular method. We will discuss this graphical method today. Then there is a simplex method. We will of course discuss this method later after 2 to 3 lectures of that learning the graphical method of linear programming. But of course we will discuss this important method thereafter, that is the simplex method. Then we will have the idea that how we can formulate the linear programming problems, because we'll have to involve some mathematical techniques and some mathematical methods in order to formulate these certain equations, and then we will be able to solve the problems related to these linear programming methods. So we will take the example of that shader electronics example. That is again the example from your own textbook of Hazer, that is the operations management by Hazer, and we will discuss this example in detail so we can have the idea that what are the different steps which are involved in resolving and solving that linear programming problems. So you can also compare the steps which we will learn today with the steps which are given in the book. So you can have the idea that how we can go through all of those steps of linear programming. Then in the coming lectures we will directly solve the different problems which are related to the linear programming. So we'll discuss about the graphical solution to the linear programming models and how we can represent the constraints. Again, constraints means limitations, that is the limitations. How we can represent the limitations in the form of inequalities or in the form of mathematical equations. Then there are two methods, sub-methods we can say. There are the two sub-methods which are used for graphical method in order to achieve our objectives. One method is known as Isoprofit line method. The other method is the corner point solution method. Corner point solution method is always and mostly used in order to achieve our linear programming objectives, but we'll also go through that Isoprofit line solution, that you can have the idea that what this solution is about. We'll also discuss about the applications of the linear programming problems. Now again students, this is a very important part of any of the operation management technique, that how this technique can be helpful for the operations manager to take some scientific decisions in order to resolve the problems in their operations, and in order to provide the quality products and services to their customers. So we'll also discuss that practical aspect of linear programming, that how these methods can be helpful in solving some practical problems faced by operations managers. So students, this is a brief course outline that is the for today's lecture of linear programming. Let's start with the definition of linear programming. Okay, before starting that linear programming, just discuss that what you will learn after going through this lecture. You will be able to formulate the learning programming models, including the objective function and the constraints function. Again, the students, whenever we are going to those linear programming problems, then we'll have to deal with some objective function, we'll have to deal with some constraints function, and we will have to find out our objectives or achieve our objective within the certain limits or constraints. Then you will be able to graphically solve a linear programming problem either with the Isoprofit line method or with the corner point method. That is again a very popular method which is always used for that linear programming. Now let's start with the definition of linear programming. Linear programming is a mathematical technique which is used to allocate the limited resources to achieve an objective. Now let's discuss on this definition. The first step or the first point in this definition is that linear programming is a mathematical technique. So it uses some mathematical approaches in order to achieve the different objectives before the operations managers. So through some linear programming problem, we are actually interested to achieve some objectives. And again, there are two main objectives which are to be achieved through that linear programming problems. That is, either we are interested in maximization of the profit or we are interested in minimization of cost. So we will discuss that how the different approaches can be used for that particular case, that is maximizing profit or minimizing cost. And again, we'll have to achieve these objectives within the limited resources, within the certain limitations. Now class, you must know that every entity has some limitation. Human resource has a limitation because we cannot work for 24 hours. If we try to work for 24 hours, we will be ill and we will not be able to achieve our objectives. Again, the machinery in the organization is not able to, sometimes not able to run for the 24 hours. There are the certain limitations, and sometimes there is maintenance required, and sometimes there is a certain time limit for which we can apply a particular resource, most importantly the machine resources. The same is true for the labor resources. So we'll have to deal the objectives or achieve the objectives within these limitations. So linear programming is a technique for optimization of a linear objective function. What is the linear objective function? Linear equation is that equation in which the power of a variable is 1. That is the linear equation. You must have known or have learned about that linear equation in statistics or some mathematics subject, that if the power of the variables involved in a particular equation is 1, that is the linear equation. So in case of linear programming, we are most concerned, or we are always concerned about the linear functions. We are not interested in the quadratic or some other functions in which the power of the variable is more than 1. So that is very important to note, that we try to optimize our linear objective function. That is the objective function in the form of some linear equation, subject to the linear equality and linear inequality constraints. Then again, as I said, that we want to achieve the objectives within the certain constraints. Now we'll have to represent these constraints in the form of either equations or in the form of inequalities. So we will discuss these different conditions of inequalities as well as the equations, that how we can represent our constraints in the form of inequalities or equations. So this is a general definition of linear programming. Then another definition is linear programming determines the way to achieve the best outcomes, such as maximizing profit or minimizing cost in a given mathematical model, and given some list of requirements represented as linear equations. So again, we have just discussed that there will be certain objectives, there will be certain constraints. We try to achieve the objectives within the certain constraints through the linear programming program. So this is what is about the purpose of the linear programming problems. And of course, it is the most powerful technique for managerial decisions. If you are able to understand this technique, you can always apply this technique in taking some good decisions, and most importantly, the scientific decisions, because again, these sort of decisions are not on the basis of certain observations or the intuitions, but on the basis of certain facts, statistical and mathematical calculations, and that decisions is always the good decision, you know, for the managers to that is based on the facts that are more logical decisions. And sometimes through the linear programming we will see that we are able to achieve the objectives or maximize the profit, that there will not be other alternative through which we can maximize our profit. So it will help us to identify the best alternative through which we can achieve the organizational objectives. So is the importance of that linear programming. So a linear programming model seeks to maximize or minimize a linear equation, as we just discussed, subject to a set of linear constraints. The linear model consists of the following components. Now class, please note down that there are three important components of linear programming, and the first component is the set of the decision variables. Now what is these variables about? We'll have to, whenever we go through the certain problem related to the linear programming, we'll have to identify that what are our decision variables. For example, if you want to determine a mix of the different products which are being produced in the organization, so that your profit may be maximized with this combination of the different products, then the number of those products to be produced within your organization will be the decision variables, because that will help us, or the particular quantity of those products and their mix will help us that how we can maximize our profit. So whenever we go through the linear programming, it is very important to find out that what are your decision variables. The next is the objective function. That is the most important function, and after going through that learning linear programming, we will just try to find out our objective, and we will try to represent it in the form of the mathematical equation. So that is the second important component of objective function, that is the either profit maximization or cost minimization. The third important component of linear programming is a set of the constraints, a set of the limitations. As I just told you that every machinery, every human resource, every entity has certain limitations, so you'll have to identify those limitations in the form of the equations or in the form of the inequalities. So these are the very important components for any of the linear programming problems. Then we will find the minimum or the maximum value of the objectives. When we are able to identify what is our objective function, then we'll be either interested to either maximize our objective function or to minimize our objective function, which may be the cost function, in which we are interested in minimization. So after we are doing all of these things, and after we are going through the linear programming steps, we will just learn, you will be able to guarantee the optimal solution to the model formulated. Now this is very important, that after this sort of exercise you will be able to find the optimum solution, and there will not be any other solution which we will compute to the linear programming, through which you can better achieve your objectives. So is the strength of linear programming method in operations management. Now let's discuss some of the applications of the linear programming, and then we will come to finally the method and proper steps of linear programming. Linear programming helps us in scheduling, maybe it helps us in scheduling the different school buses to minimize the total distance traveled. So whenever you are involved in some transportation process, this method can be very helpful in defining the different transportation routes and defining the different schedules, so that your cost of transportation may be minimized. So that may be one of the purpose of linear programming. Then we are always interested to allocate the certain resources in order to minimize the response time. Now, in every organization, all the managers are interested to minimize the response time to the certain requirements. So, of course, linear programming can be very helpful in achieving that particular objective. Then it may also be helpful in the banking scenario in order to schedule the different tellers at the banks so that needs are met during each hour of the day while minimizing the total cost of labor. So that is another very important application of linear programming. Then of course another most important application of linear programming is that it helps us to select the product mix in a factory to make best use of machine and labor hours available while maximizing the firm's profit. So what linear programming guides us? It guides us to maximize the profit through the limited resources, that may be the machine resources, that may be the labor resources. So through this method of linear programming, we will be available to achieve these objectives within the minimum possible time and with the optimum utilization of our resources. Then it also can help us in picking the blend of the raw materials in feed mills to produce finished feed combinations at the minimum cost. Again, it can help us to find out the combinations of the different raw materials which can be used in the production of the final products and services, through which we can maximize our profit, or the cost of the production can be minimized. So this is the particular strength and application of that linear programming. Then we can determine the distribution system that will minimize the total shipping cost, as we have discussed that in transportation scenario and in shipping scenario we can minimize the total shipping cost with respect to that linear programming methods. Then it helps us to develop a production schedule that will satisfy future demands for a firm's product and at the same time minimize the total production and inventory cost. So again, we can have some optimum solution for our production as well as for our inventory in order to maximize the profit or in order to minimize the cost. So these are some of the applications of linear programming, and other than these applications, we can always use the linear programming in the different situations in the organizational setting. Throughout our lectures of linear programming, we will also discuss some important examples, some important scenarios that how we can apply these methods in the working environment of the organizations. Now again, let's discuss about the requirements of the linear programming. The first requirement of the linear programming is there should be an objective function. Again, as I have discussed, that after going through the linear programming related problem, first of all we'll have to identify the objective function, either the profit maximization or the cost minimization. Then the second step or requirement is the restrictions or the constraints are present which limit the ability to achieve objectives. So what is the second requirement? We'll have to identify the different constraints. We have to identify the different limitations within which we can work and within which we should be able to achieve our objectives. The third requirement of linear programming, there must be an alternative courses of action from which to choose. When we will go through the different steps of solving the linear programming problems, then you will find that after defining about the objective function, after defining the constraints in the form of equations or inequalities, finally we will discuss a method through which we can have the different alternatives, and going through that alternatives we will have the idea that what is the best alternative through which we can achieve our objectives. Last step is, or the last requirement is, the objective and constraints in the linear programming problems must be expressible in terms of linear equations or inequalities. Now again, as its name refers, that is the linear. We are interested in the linear equations. If you are not being able to represent our objective function or our constraints in the form of linear equations, then we can not solve such problems with the help of this technique of linear programming. So that is another requirement of linear programming. These are some of the very important steps which we will go through while solving the different problems of linear programming. Now students, these are so important steps that after attending this lecture, you should have these steps on your fingertips, that what is the first step, what is the second step. Then it will be helpful for you to solve the different linear programming problems. If you are going to remind always these steps of linear programming, then you will see that you will start enjoying the linear programming problems. What is the first step? Again, we'll have to study the given situation. Now this is very important sometimes, and sometimes in the operations management scenario we say that if you rightly identify the problem and rightly analyze the problem, half of the problem is actually solved. So important is the proper examination and the analysis of the situation. So we'll have to analyze the situation, what is the requirement, what is the objective function, what are the constraints. That is the first step. Then we'll have to find the key decisions to be made, what decisions in which we are interested. Either we are interested in the minimization of the transportation cost, or we are interested in the maximization of the profit through the combination of the different products. So what actually are the decisions we are to be made after this method of linear programming. Then we'll have to identify the decision variables of the problem. We have just discussed that if you are interested in the product mix, then the quantity of this product mix for the different products will be your decision variables. So we'll have to identify what are the decision variables. In the second step, you'll have to formulate the objective function to be optimized. Formulate means we'll have to represent our objective function in the form of some linear equation. So after going through the steps, you'll have the idea that how we can formulate this linear equation. But for the time being, you just go through these steps and remember these steps, and you should have these steps in mind when we will start solving the different problems of linear programming. Step 3, formulate the constraints of the problem. We'll have to identify the constraints, and we'll have to represent these constraints in the form of linear inequalities. Then again, there are some non-negative restrictions or constraints which will have to be represented in the form of equations. So these are some of the important steps which will have to be gone through for solving some linear programming problems. So let's take the example in order to solve that linear programming problem. Again, class, this is example from your textbook, and you can always go through your textbook in order to have the idea that how we can solve these problems. Okay, we are interested in the product mix problem at Shader Electronics. The manager is actually interested to find the quantity of the two products in order to maximize the profit. There are the two products, that is Shader Export, a portable music player, and there is another product, that is the Shader Blueberry, an internet connected color telephone. Determine the mix of the products that will produce the maximum profit. Now there are the two things. One is the objective. What is the objective? We want to maximize the profit. What are the products? There are two products, that is the Shader Export, which may be represented by the X1, and the Shader Blueberry, which may be represented by X2. Now what is X1 and X2? Actually, in this particular problem, we are interested to find out the quantity of these two products which can maximize the profit. So we can suppose that that required quantity is X1 for the Shader Export and X2 for the Shader Blueberry product. So that is the X1 and X2. In this particular case, this X1 and X2, which is to be calculated through that linear programming problem, are actually our decision variables we were talking about. So X1, X2, that is the quantity of Shader Export and the quantity of Shader Blueberry are our decision variables. Now this is the table of this particular problem. Let's go through this table. There are the two departments. One is the electronics department, the other one is the assembly department. There are the two products to be produced. One is the exports, the other one is the blueberries. And what are these figures about? It shows that there are 4 hours are required to produce 1 unit of export. That is the electronic hours required. Again, there are 4 electronic hours are required to produce 1 unit of export. And similarly, there are the 3 hours required, electronic hours are required to produce 1 unit of blueberry. Now this is represented by these figures, and here is the available hours this week, that per week you cannot do more than 240 works of electronics on either products, either the product 1 or the product 2, that is exports or blueberries. So this is your constraints, that you cannot work beyond this limit of working hours. Then again, this 2, what's 2? There are 2 assembly hours are required to produce 1 unit of exports. There is 1 working hour is required to produce 1 unit of blueberry. So these are the assembly constraints. And what are the total assembly constraints? That is the 100 hours. We cannot work more than 100 hours for the production of these products. Now profit per unit. There is a $7 profit on 1 unit. If you are able to produce 1 unit, there will be a 7% profit on that particular unit. And if you are able to produce 1 unit of blueberry, then the profit will be $5. So this is our profit related figures. Then in this case, what are our decision variables? As I said, that number of exports to be produced. Now this is to be determined through this method, that what unit of exports and what units of X2 should be produced by the manager, so that their profit may be maximized. So this is all about this table. And after analyzing through this table, what is the next step? Now we should be able to define the objective function. As I told you, that objective function definition is the first and the foremost requirement of linear programming. Now maximization of the profit, or the maximized profit function, is equal to 7x1 plus 5x2 . Now how you formulate this profit function? Let's discuss again that table. There is 1 unit. If you are able to produce 1 unit of exports, then there will be $7 profit. And if you are producing, suppose x1 number of products, then the total profit for this particular product will be 7x1. Is it clear? If you are able to produce 1 unit of x2, the profit will be $5. If you are able to produce 2 units of x2, the profit will be of course $10. But if you suppose that we are able to produce x2 units of blueberries, then the total profit for this particular product will be 5x2. And if we combine the profit of both x1 and x2 for this particular production of x1 and x2, then the total profit function will be 7x1 plus 5x2. This is the way we formulate this equation of profit, that is 7x1 plus 5x2. So this is our profit function, and this profit function may sometimes represented by z, or maybe sometimes represented by f. So that is the major objective function which is to be maximized. Now what are the constraints? What are the limitations in this particular case? There are the 3 types of, generally speaking, there are the 3 types of constraints in linear programming problems. One are the upper limit constraints, where the amount used is less than or equal to the amount of resource. Now that is very important. In this particular case, you can see that the constraints are the electronic constraints and the assembly constraints. And what are these constraints? One of the constraints is we cannot do more than 240 hours for the electronic work. Now that is the constraint of that machinery related to electronics. Again, we cannot do or apply more than 100 hours for assembly. That is again the assembly constraints. So we will have to work within these constraints. So one type of the constraints are related to the less than equal to figure. In this particular case, we are interested in less than, because the total capacity of the electronic work used should be less than the capacity available. So that is very important. We will use that less than and equal to constraint in this particular case. What can be the other constraints? These may be the low limit constraints, where the amount used is greater than or equal to the amount of the resource. In this particular problem, we are not interested in that greater than or equal to constraint. In the preceding problems, we will discuss that what are the situations in which we will have to use these greater than or equal to constraints. then there are some equalities where the amount used is equal to the amount of the resource. If we say that the total electronic work should be used is equal to this, then that will be the equality constraint. But in this particular case, or in this particular example, this is the less than or equal to constraint, that is total electronic work should be less than or equal to 240. Now if we try to formulate this constraint for electronic works, you can see that if we are able to produce 1 unit of export, it will take 4 hours of electronics. So अगर हम x1 प्रोडक्ट्स इसमें प्रोड्यूस करते हैं तो हमारा जो टोटल इलेक्ट्रॉनिक वर्क है फॉर दिस प्रोडक्ट x1 दैट विल बी 4x1, ठीक है. और जो अगर x2 यूनिट्स प्रोड्यूस करते हैं देन दैट विल टेक 3 आवर्स पर यूनिट, एंड व्हाट विल बी द टोटल इलेक्ट्रॉनिक आवर्स, दैट विल बी 3x2. सो आवर टोटल कांस्टेंट फॉर इलेक्ट्रॉनिक्स विल बी 4x1 plus 3x2 less than or equal to 240. Why less than or equal to? Because we'll have to keep this electronic constraint or electronic limitation within the limits of that 240. We cannot work equally or beyond that limit. So this is the first constraints we will have to form in this particular equation. Then what about the assembly constraint? अगर हम x1 प्रोडक्ट प्रोड्यूस करते हैं तो एक प्रोडक्ट के लिए 2 आवर्स चाहिए आपको असेंबली वर्क के लिए. अगर आप टोटल x1 प्रोडक्ट्स प्रोड्यूस करते हैं, नंबर ऑफ x1 प्रोडक्ट्स प्रोड्यूस करते हैं, तो द टोटल असेंबली आवर्स फॉर दिस पर्टिकुलर केस विल बी 2x1, एंड फॉर दिस प्रोडक्ट इन द सेम वे विल बी 1x2. सो द टोटल assembly hours used for the production of x1 products of exports and x2 quantity of blueberries will be 2x1 plus 1x2, and that should be again less than or equal to 100. So this is the way we will have to identify our objective function. We'll have to identify our constraint functions. So as we have just discussed that in this particular problem our maximization profit is equal to 7x1 plus 5x2, and what actually is the requirement? We want to determine the value of this x1 and the value of this x2 through which this profit can be maximized. So this is what is required in this particular problem. So as we discussed, that first constraint is the electronic time used. This electronic time used for both the products, product x1 and product x2, should be less than or equal to the electronics times available. Is it clear? So this is the first constraint. So what total electronic time used for the production of x1 quantity of product 1 and x2 quantity of product 2, that will be 4x1 plus 3x2. Now this whole total should be less than or equal to 240 hours, because these hours of electronic time is available. So this is one of the constraint. The second constraint is the assembly constraint. Again, the total assembly time used for the production of x1 quantity of product 1 and the x2 quantity of product 2 will be 2x1 plus 1x2, should be less than equal to 100. That is the capacity of assembly work. So in this way we will have to convert those statements or tables or the information in the representation of constraints in the form of these inequalities. Now let's talk about the graphical solution. Graphical solution can be used when there are two decision variables. Now keep in mind, mostly we can apply this linear programming method when we are having the two decision variables. When there are more than two decision variables, then we can solve them by another method, that is the simplex method. We will learn the simplex method after this linear programming. So for the time being we are interested in the decision variables, that is the two decision variables. Now the first one, you will have to plot the constraint equations and their limits by converting each equation to an equality. Now what we will do, अभी हमने जो इक्वेशंस बनाई हैं constraints की, एज अ फर्स्ट स्टेप हम क्या करेंगे, जो इनइक्वालिटी है दैट इज लेस देन और इक्वल टू, इसको हम इक्वल टू में चेंज कर देंगे, और उसके बाद एक मेथड यूज करेंगे बाय पुटिंग आइदर द x1 0 और द x2 0 टू आइडेंटिफाई द डिफरेंट पॉइंट्स, एंड देन हम उन पॉइंट्स को एक ग्राफ में ड्रॉ कर लेंगे बाय टेकिंग द x1 ऑन द x एक्सिस एंड बाय टेकिंग x2 ऑन द y एक्सिस. सो दिस इज द फर्स्ट स्टेप, दैट विल हैव टू ड्रॉ दीज कॉन्स्टेंट्स इन द फॉर्म ऑफ लाइन्स ऑन अ पर्टिकुलर ग्राफ. Then we'll have to identify the feasible solution problem. Through that graph or through that lines, we will be able to identify that what is the most feasible area for this particular scenario. So we'll just discuss it. Then we will try to create an isoprofit line based on the objective function. इसके बाद हम कोई एक हाइपोथेटिकल वैल्यू ले लेंगे ऑब्जेक्टिव फंक्शन की और उसको हम उसमें उसी ग्राफ में उसको ड्रा करेंगे. सो जस्ट कीप इन माइंड दीज स्टेप्स. वी विल डू दीज स्टेप्स इन द नेक्स्ट प्रॉब्लम वी आर गोइंग टू सॉल्व. Then we will move this line outward until the optimum point is identified. Against class, please remember we are interested in the less than constraints. Whenever there is a less than constraint, then in this particular case we will be interested to move this profit line outside in order to find the optimum point. So don't be scared about these steps. We will just discuss these steps. I am going to tell you these steps so that you can have these steps in your mind when we are going to make that diagram, and then you can better understand these steps. Now this is our first constraint, that is 4x1 plus 3x2 is equal to 240. Now what we did, हमारा जो constraint था उसको हमने equality में change कर दिया. Now this is a method which is being applied in the linear programming. कि हमारा ये फर्स्ट इलेक्ट्रॉनिक कांस्टेंट है जिसको हमने इक्वेशन में चेंज किया, इनइक्वालिटी में चेंज किया, उसके बाद उसको इक्वालिटी में चेंज कर दिया. नाउ वी विल हैव टू फाइंड आउट द डिफरेंट पॉइंट्स. हाउ वी कैन फाइंड द डिफरेंट पॉइंट्स? फर्स्ट ऑफ ऑल वी विल पुट x2 is equal to 0 in this equation. Now when we put x2 is equal to 0, then 4x1 will be equal to 240 and x1 की वैल्यू हमारे पास क्या आ जाएगी? 60. So this is x1 is equal to 60. In this way we will have the point that is 60 0. That is 60 is for x1 and x2 is as 0. So this is a particular point. We will have to draw this point on the graph. In the same way, we will put now x1 is equal to 0 in the similar equation. If we put x1 is equal to 0, then x2 की वैल्यू हमारे पास क्या आ जाएगी? 80. So this is another point 0 80. Now both of these points, this point and these points are related to this particular constraint or equation, that is equation number 1. In the same way, this is the second constraint which is converted into the equality. Now this is again the method of linear programming. Now again we will adopt the similar method. First we will put x2 is equal to 0, then x1 will be 50. By putting this value of x2 in this equation, we get x1 is equal to 50. So this is a point x1 and x2, 50 and 0. If we put x1 is equal to 0 in this particular equation, we will get x2 is equal to 100. So there will be another point 0 100. Now students, what we did, we use these, we convert the two of the inequalities into equations, and one by one, by putting the different variables in both of these equations, we got 2 points for this equation and 2 points for these equations. Now we are able to draw these points relating to these particular equations on a graph. Now this is the graph. Now in this graph, the number of the exports which are actually represented by x1, that is taken on the x-axis, and the number of blueberries which is actually represented by x2, that is taken on y-axis. So this is the y-axis, this is the x-axis, that is the x1 on x-axis, x2 on the y-axis. Now we will take a particular scale according to your own convenience. In this particular case, we will have the we can have the scale with respect to that 10 points difference. This is 10, 20, 30, 40, 60, 80, 100. Again 20, 40, 60. According to the particular values of equations, you can take any most convenient scale in the form of these paragraphs. Now we'll have to draw those points. Now these points we just calculated. For the equation 1, point is 60, 0 and 0, 80. Now if we draw these points on the equation, this is the point of 60 and 0. It means that when x1 is equal to 60, x2 will be 0. Now on this line, this is the value of x1 as equal to 60. And in this on this x-axis, the value of y is 0. That is, the value of x2 is 0 actually. So this is the point 60, 0. We will put a point here. Other relevant point with respect to this particular equation was 0 and 80. That is, when x is equal to 0, y will be equal to 80. So this is the 80 point. Now we will connect these 2 points, and these 2 points are actually represented our first equation. Is it clear? Again, I repeat it. By calculating these 2 points through these equations, now we will put these points in the graph in order to represent them in the form of the equations. This is the first point for first equation, that is 60, 0. The other one is 0, 80, and we will connect these 2 points, and actually this is the line of our first constraint, that is 1, that is represented by equation 1. Now similarly put the points for the second constraint. The first point was 50, 0, and the other relevant point was 0, 100. So we'll here, this is the point on x-axis where x is equal to 50 and your y value is 0. On x-axis the value of y is 0. So this is the point of 50, 0, and this is the point of 0, 10, that is x is equal to 0 and y is equal to 100. So we will connect these 2 points. Now this line is represented by equation number 2, that is actually the second constraint related to the assembly constraint. So this is the electronic constraint line and this is the assembly constraint line. Now class, after drawing these 2 lines, we will draw some feasible region. Now because we were interested in the less than constraints, this is the line of assembly constraint. Now we cannot go beyond this line, because we cannot go beyond the limit of that assembly line. So our feasible area for this particular line, that is line number 1, will be less than area of this line. Similarly, the feasible area for line number 2 will be less than of this particular line. But we are interested in both constraints, because we will have to fulfill the electronic constraints as well as we will have to fulfill the assembly constraints. So our feasible region, which is less than, out of this region, which is less than, that is less than both of the lines, that is line number 1 and line number 2, is this one. This is the feasible region, that is, this is the feasible region under which we can operate, under which both of the assembly constraints and both of the electronic constraints can be fulfilled. So we can operate under this feasible region. Now again class, let me repeat it. These are the 2 lines for the 2 different equations. Now we'll have to find out the region which is less than both of these 2 lines, which is less than both of these 2 lines. Now this is that region which is less than for the equation for the line number 1 as well as less than for the line number 2. So this is our feasible region. Now what we'll do next, we will have to draw a profit line on this particular graph. For that particular purpose, we choose a possible value for the objective function. Now this method is known as Isoprofit line solution method. This is our objective function, that is objective function is equal to 7x1 plus 5x2, but in this particular case we have taken an hypothetical value. You can take any value. Suppose we are taking that objective function as 210, then this will be the equation for the objective function, and we will solve again this equation. If we put x1 is equal to 0, then the value of x2 will be 42, and if you put x2 is equal to 0, the value of x1 will be equal to 30. So this is again a point of 30 and 42, and we will draw this point on this particular graph. This is the line of this objective function. This is the objective function, that is 7x1 plus 5x2, but hypothetically we take any value of 210. We equate this objective function equation to 210. Now this is a hypothetical value. You can take any value, but such value that this profit line should be within that feasible region. That is important. If we take some value of 800 here or some value of 1000, that line may be beyond this feasible region. So that is not the case we should focus on. We should take such value, hypothetical value of profit, that our profit line should be within the this particular feasible region. So this is our initial profit line. Now what we do in case of less than case, because this is the particular example of less than constraints. So whenever we are interested in the less than constraints or we are interested in the profit maximization, we will try to move away this profit line. Now if we put that profit is equal to 280, then this will be the equation, and similarly if we put x1 is equal to 0, we will get the value of x2. We will put, if we put x2 is equal to 0, we will put the value of x1, and again we will put those values of x1 to have this parallel line of profit, some other value, this line, as far as we will increase the value of profit on this left hand side. This profit line we will move ahead towards that the final limit of the feasible region. Now suppose if we put that value equal to 480, now this is the profit line which is actually the last feasible point of that feasible region. Now this is the point where this last profit line is meeting the last limit of that feasible region. This is the optimal point. Now how this is the optimal point? When we are going to move that profit line away, then the last point where this profit line will touch the last or the last peak of that feasible region, that will be the optimal point. And if we compare with respect to the graphs on x-axis and y-axis, we can see that this point, the value of x-axis on this point is 30 and value of y-axis on this point is 40. That is our x1 which is on x-axis will be 30 and a value of x2 which is on the y-axis will be 40. Now class, this is the point or the decision variable values which can maximize your profit. What it means that if we are able to produce 30 units of x1 and 40 units of x2, then we will be able to maximize our profit. And what will be that maximum profit? That will be equal to 410. So please try to remember these steps, that after drawing the constraints in the form of the graph, we will draw a hypothetical profit line by taking any suitable value so that that profit line remain within that feasible region. Then we will try to increase the profit value on the left hand side so that that profit line moves upward towards that last point of feasible region. And when we are able to have a profit line which actually touches the last available point of feasible region, then that will be the point of optimal point, and that will actually maximize the profit. So this method we just discussed is the Isoprofit line method. But generally we don't discuss that Isoprofit line method. We mostly use that corner point method. Now research says us, or this method guides us, that your profit will be maximized on any of the corner point method, and that's why this is known as corner point method. Now again class, this is the graph, this is our first equation, this is our second equation. Now what are the corner points? One corner point is represented by 1 here, the second corner point is 4, third corner point is 3, and the fourth corner point is represented by 2 here. Now these are the corner points of that feasible region. Please remember, this is the feasible region. This is also a corner point, but that doesn't lie in the feasible region. Similarly, this is also a corner point, but that doesn't lie in the feasible region. We cannot use these corner points. So here in this particular case, there are the 4 corner points, that is 1 where x is equal to 0, y is equal to 0, 2 where the corresponding value of x is equal to 0 and the value of y is 80, that is the point 080. Third one is this represented by 4 here. This will be equal to 50 and 0 because x-axis value is 50 and the y-axis value is 0. And this is another point whose value we don't know up to now. That is the intersection of both of these lines. That is the line 1 and that is the line 2. So we will have to determine this point 3 through the intersection method of solving the different equations. Now this is the point of intersection of the equation 1 and equation 2. Now these are the 2 points whose coordinates we already know, that at the point x1 we have x1 is equal to 0, x2 is equal to 0. Now that is a very basic solution in which we are not interested, of course. That is, we don't produce anything. If we put this x1 value and x2 value in the profit function. Now class, this is the profit function. Our basic profit function was 7x1 plus 5x2. So we will put these relevant values of x1 and x2 in this profit function and we get the profit is equal to 0. So this is the solution in which we are not interested. The second feasible solution is at the point 2 where x1 की value is 0 और x2 की value कितनी है 80. Now we will put this x value of x1 and x2 in this equation, that is x1 is equal to 0, x2 is equal to 2. Then the profit function will become 400. मतलब इसका क्या है कि अगर हम x1 कोई यूनिट प्रोड्यूस ना करें और 80 यूनिट्स ऑफ x2 प्रोड्यूस करें तो हम फिजिबल एरिया के अंदर प्रोड्यूस कर सकते हैं. रिमेंबर दैट विद इन द लिमिट्स ऑफ इलेक्ट्रॉनिक्स एंड असेंबली दैट इज फिजिबल. and in this particular case the profit will be 400. Then another feasible point is 4, where x1 is equal to 50 and x2 is equal to 0. If we put these values in this profit function of 7x1 plus 5x2, then we will get the value of profit as 350. Now this is another combination. If you don't produce x2 and if you only produce x1, then it will be produced in quantity of 50 and the profit will be equal to 350. Now these are the 3 points. But you remember we have another point, that is the point 3, which is the intersection of line 1 and line 2. So we will have to determine the value of this intersection by solving these two equations. Again, these are the two inequalities. We will convert these inequalities into the equalities, and we'll compare the coefficients of any of the variable to become equal, so that we can subtract and we can find the value of the other variable. Now this is the common intersection method through which we solve the different equations. You must know about this method. Now what we did, we convert them into inequalities and we multiply the second equation by 2. Why 2? Because जब इसको हम x1 के कोफिशिएंट से मल्टीप्लाई करेंगे तो x1 के जो कोफिशिएंट है दोनों बराबर हो जाएंगे, और जब हम इसको स्टेप करेंगे तो एक चीज़ कैंसिल हो जाएगी, and we can be able to find the value of the second variable. So we will subtract this x1 and 3x2. Okay, when we will subtract it, of course the symbol of this second line equation will be changed. Now 3x2 minus 2x2 will be equal to 1x2 is equal to 240 minus 200. This will be equal to 40. Now if x2, in this way we can find the value of x2 is equal to 40. Now put this value of x2 either in this equation or in the second equation. We can get the value of x1. In this particular case we can get the value of x1 as equal to 30. So class, in this method we are able to find out that point of intersection of line 1 and line 2. And what is that point of intersection? That is 30, 40. That is the value of x1 is equal to 30 and the value of x2 is equal to 40. Now we have all the 4 available corner points. That is the corner points available for that feasible region. Point 1 we already have calculated. For point 2 we have already calculated the profit. For point 4 we have already calculated the profit. And now we have also calculated the point of intersection of line 1 and line 2. And what is that point of intersection? At that point of intersection, the value of x1 is equal to 30 and the value of x2 is equal to 40. And we put again these values into the profit equation, that is 7x1 plus 5x2, and we get the value of profit is equal to 410. So class, you remember when we were defining the linear programming, then I told you that we should have some alternatives. So these are the simple alternatives which can be used by the production manager or the operations manager. And what is the best alternative? Of course, this point 3 is the best alternative. That is, the manager should produce 30 units of product 1 and 40 units of product 2, and then the profit will be maximized. And what is the value, maximum value of the profit? That is $410. Other than that alternative, there is no other alternative available through which we can maximize our profit. So this is all about the linear programming method. And let me repeat it, that what are the different steps? We define the objective function, we define the constraints, we convert those objective functions into the equations or the inequalities. We draw that inequalities into the graph. Then we can use and we can be able to identify the feasible region. Then there are the two methods. One is the Isoprofit method and the other one is the corner point method. Then by using either of these methods we can maximize our profit. So class, this is how we solve the linear programming problems. For the first problem, I explained all of these steps in detail, and again, you should always have these steps on your fingertips so that we can, in the proceeding lectures, we will be able to solve more problems by using this sort of method. And of course, we will do some minimization problems, and we will solve some problems in which more of the constraints are involved, And finally, we will also discuss about the simplex method at the end, that is another method of linear programming. So class, thank you very much for your patience, and I hope you will go through this lecture of linear programming before going through that next lecture, because we will discuss some important and related problems relating to that linear programming in the forthcoming lecture. Okay, have a good time. Thank you very much. Khuda Hafiz.